So the question is find pivot index. By pivot index, we mean from the left of the pivot, we calculate the sum. Let's say I is 3. If it is a zero-based indexing, then 2, let's say. So left sum is 7 plus 1, 8, and right sum is 6 plus 5 plus 6. That's 17. So that is not a pivot point. So according to pivot point, uh, the elements to the left of that pivot is called left sum, and elements to the right of that pivot is called right sum. And these left sum should be equal to right sum. Then only the particular index that we assume to be pivot point is called the pivot index. So, like, we can go for the brute force first. So let's say we check one. So zeroth index can be also pivot point. So basically, right sum will be this and left sum will be 0. So how come it is possible? Because in the question it is written that uh, basically the numbers can be positive as well as negative. So if the numbers are negative on the right, so let's say the sum turns out to be 0. So the left sum will also be 0. So that time the pivot index will be 0, which is this 1 at 0th position. And if such index does not exist, then we return -1. And what exactly we have to return? Leftmost private pivot index. So it's possible that there is comes an index where left sum is equal to right sum on the right side and on the left side also. So we have to return the leftmost. Okay, so the brute force would be check for each pivot for from 0 to n minus 1. Check the left sum, check the right sum, and then see if both are equal. So for each index, we have to calculate left sum, right sum, and so that time complexity will be n square. Now let's see how we can optimize it. So still, if we take like for each index, if we can calculate the left sum, right sum on the fly, like order of 1, how can we do that? Something on the lines of like if we can pre-compute something. So what we can do is we can have something like uh, total sum. So if we calculate the total sum and if we keep calculating the sum till this point, that way we know the sum till here, and the right sum we can calculate through total sum minus the left sum, and that's how we can just do it in order of n. So yeah, let's see. Let's implement the code. Okay, here let me make a dry run. So let's say we are at 1. So left sum is 0. And okay, first we calculate the total sum. So total sum will be 1 plus 7 is 8 plus 11, 17, 22, 28. So total sum is 28. So left sum at 0th index is 0 and right sum is 28 minus 1. That will be 27. So it's not equal. Then again we do for 7. Then again we do for 3. Then again we do for 6. So at 6 we have left sum as 1 plus 7 plus 3. That will be 7 plus 3 is 10 and 11. And the right sum will be 28 minus left sum minus 6. That will be again 11. So we can see 3 is the pivot point. So basically this 6. So this is at position 3. So this is the pivot index. And obviously if we don't find any pivot index, we can just say it's not present and return -1. Let's see the implementation. So we need first we need to calculate the total sum. So first we see the size of the array. Now let's calculate the total sum. Initialize it to 0, then loop it over. So this is how we get the total sum. So let's calculate left sum on the fly and also have something like right sum. So let's go for like looping over the array. So here what we first check is we calculate the right sum. So right sum would be total sum, that is sum in our case, then subtract left sum, then subtract the current uh, index. That's how we get the right sum. And if left sum is equal to right sum, then we return that particular index. Else we just calculate, we keep calculating the left sum. So we just add the that particular index value. And obviously if we don't find any, we return -1. Okay, let's try to run this. Okay. So yeah, accept it, submit, and yeah. So 19 seconds, reach 58% of users. So yeah, so this is the whole code. Thanks guys.